example, we're going to say you're standing on a bridge, okay, and the bridge is 50 meters tall. You decide to drop a stone off the bridge, and you're given these coordinates that represent the time and the height of the stone. So, when you're standing on the bridge, you're holding the stone, you're 50 feet above. What time are you going to be at there? 0, that's right. Okay, so at 0 you're at 50. Then let's say at 2, you're at 49.5. At 4, you're at 47.6. At 6, you're at 44.4. Oops, 44. Thank you. And at 8, 40.4. And at 10, you're at 35. That's all the information we're going to say you're given. All right, so I just changed the graph there a little, guys. So we have these numbers they've given us. We'll do it in red. Very first thing I'm going to do is I'm just going to plot them, okay? So I have 0 and 50. Going to be right there. My 2 is at 49. So that's very, very close. So I estimate about there. 4 is 47. So once again, still very close. 6 is at 44. So I'm just below 45. 8 is at 40. 10 is at 35. So that's where we're starting to get a change. So this is all the information they've given us. What we need to do here is we need to make a line of best fit. We're going to estimate to where this graph is going to go. So I'm going to start connecting the dots, try to follow the trend down. There's my estimate. Obviously, my standing up on this pad, I don't draw the greatest line, but like I said, that's my estimate, and that's reasonable for what we have right now. So what's very important is what I was aiming for, is I drew our x-intercept at 18. So that means one of the points on this graph are going to be 18 and 0. That is our x-intercept. Now, we said we were on a bridge dropping a stone. So what that means is that's the highest point. That's going to be our what? What are we going to call that? Vertex. That's right. That's the vertex of the parabola. So that would be at 0 and 50. We know the stone wouldn't be higher than that. Now, right now I only have what looks like half a parabola. Okay? How would I estimate the other side? What would the other side look like? Yeah, so what would my other x-intercept be on the other side? Negative 18. Now, I know that goes off our graph here. It'd be somewhere out there. But because this is a mirror image, a parabola, this is our axis of symmetry, comes right down the vertex. That's our axis of symmetry. So our first x-intercept is positive 18. Our second x-intercept is going to be negative 18. So we can estimate that. Mr. Blanfo, with our two x-intercepts, this is now very similar to the question where we had in example 1. I have two x-intercepts and I have a vertex, or at least another coordinate on the parabola. So what that means, this question wants us to make a quadratic expression. So what they're talking about is they want a y equals ax squared plus bx plus c. I'll write those in a second. Y equals ax squared plus bx plus c. We need to make an expression that looks like that. So we're going to go into our factored form. Our y is equal to a, x minus r, x minus s. Okay? So now that I have my x-intercepts, I can plug in values for r and s. They're going to be negative 18 and positive 18. So let's put those in. X minus negative 18. It doesn't matter which bracket you put it into. And x minus positive 18. So we have those values there. Along with that, remember what we're trying to do is we need to solve for this a. That's our goal right now. We're trying to solve for the a in the question. So I need a value for my y and my x. Well, I've been given the vertex up here. Our vertex was 0 and 50, so I can plug those values in for our x. So my y value is going to be, what, 0 or 50? 50. Why did that come out in blue? Oh, shoot. My fault. X. Now this is going to become a plus 18. This is going to become x minus 18. So I replace my y. What will I replace my x values with? 0. That's right. Our vertex was at 0 and 50, so I can replace my x values with 0. That's 18. Whoops. Minus 18. Okay? So, now that I've, oh, excuse me. Now that I've plugged all that in, I can expand and simplify it. I just need to isolate A. So we have our 50 is equal to A. This becomes positive 18. This becomes negative 18. 50 is equal to, oh, I've given different values here. Okay, yeah, that's right. It becomes negative 324A. And then, here, whoever had that calculator, I want you to tell me what this is. When I divide both sides by negative 324, mental math, yeah. 0. What is it? 1.5? I like that. That's good. Is equal to A. So, I now have a value for my A. We take a look. My value for my A is 0.15. 2 decimal places is fine to round to. So, now that I have that, I have to go back again to my factored form. This time, we're not going to put values in for our X and our Y. So, factored form again. I'm just going to do it here so we have room. Factored form. Remember, it is Y is equal to A. X minus R, X minus S, and we have Y is equal to, we substitute 0.15 in for our A value there, and we have X subtract. Now here's where I'm going to, once again, I'm going to plug in my zeros, my X intercepts. So we had negative 18 from before, and we have positive 18. Okay? We expand and simplify. 0.15, X plus 18, X minus 18. Okay? And like we said before, this goes back to our last chapter. I have my 2 brackets. I'm going to FOIL these 2 right here. I'll deal with that first, then I'm going to deal with my 0.15 after. So we get Y is equal to 0.15. And I'm going to quickly FOIL this. X squared. This becomes, I think it becomes 0, but positive 18x. Yeah, minus 18x. Minus, what number we have? 324. Oh, I'm running out of the screen. I'm going to move this over a little, okay, guys? Y equals squared minus 324. These two 18s cancel each other out. Y is equal to 0.15 x squared subtracted by, who can help me out? 48.6, that's what you got? 48.6. So if we take a look at this compared to our standard equation, guys, we're used to seeing y equal to x squared plus b at x plus c. I'm just going to quickly show you how this compares. If you guys take a look here, my a value, 0.15. Do I have a b value right now? No, there's no b value, and that's fine. You can still have a quadratic expression with no b value. My c value is negative 48.6. So that was my expression right there, my quadratic expression for me throwing a rock off of a bridge. This represents the expression. So let's say you estimated different zeros. If you were between maybe 14, like I said, and 22, I would be okay with that. If you were to draw a line, though, that looked like this, and it was a straight line, and you estimated some zero at like 30, that's not a good estimate, okay? We're thinking of a quadratic expression, so we have to make a line of best fit. So maybe you drew it and it looked like this, and you estimated 16. Or maybe you drew it and it looked like this, you estimated 20. As long as you still carry out the right process, I'm fine with it. So as long as your numeracy is right, you carry out the right numbers. Obviously, your expression is going to be different, but as long as you do the right process, I'm fine. So make sure it's a relatively logical estimate. I don't want to see something like this. That's no good. Okay?